All right. Well, good evening, folks. Thanks for showing up for another AWS Portsmouth user group event. Tonight, my good friend Tim Davis, we go all the way back to the VMware days, is going to talk about infrastructure as code, automating your deploys for the AWS crowd. That's a important thing to think about from CloudFormation template perspectives and CI/CD pipelines and making sure that your infrastructure, if it breaks, how it fixes itself and how you can update it on the fly. Oh, there we go. And so but before we get into it, a couple of show notes. If you want to learn more about the AWS Pug, Mr. Planky has made a lovely website and it's
a mediocre website.
Don't blame me for that.
All the credit. There's a website. It's hosted and it's not down right now, so that's the starting point.
It's not broke, so which is better than some. So if you want to learn more about us, or if you want to follow us, we're at AWS Pug. And if you want to join the Slack, you can join the Slack on awspug.slack.com. As always, a huge thank you to our sponsors, Liberty Mutual Insurance, Seaglass Technology Partners, O'Reilly, and of course, AWS for providing us with pizza in the non-pandemic times, books in the pandemic and non-pandemic times, job opportunities in both again, and free compute credits and lovely swag items and stickers from AWS. So with that, at VTimD, Mr. Tim Davis, he's got some good stuff on Twitter if you want to give him a follow out there. He has been in the industry for a long period of time, very smart fellow. I've been chatting with him and following him out since like I said, since the old VMware days where he was cranking out some really fun DevOps and advocacy material back then. And now let's hear what he's been up to since then, Mr. Tim.
Excellent. Thank you so much for that lovely intro. I appreciate that. And if you follow me on Twitter, you will, well, if you follow me for tech, you're going to be sadly disappointed because my ratio of barbecue and other shit posting to tech ratio is very small.
I guess I should have specified. And Audi fanboydom.
Oh, yes, that's me. Absolutely. 100%. Shout out to my 2017 TTS. All right. So let me pull.
You're probably going to want to share your screen.
I am getting to where I need to be with that. I am sharing my screen right here.
All right.
Close my friend's search there. All right. So speeding up development with infrastructure as code and dynamic environments, or whatever name it is that I gave Chris for this specific presentation. There's lots of different things involved with this. I kind of mix up a few things, but really, normally when you have 45 minutes or whatever the presentation time is, I'm looking at you in real life, asking you questions, polling the audience and stuff like that, and my content takes 45 minutes. If I am in fact not doing that, or you're not asking me questions, then we're gonna be done in about 15 minutes or so. So we'll figure that out. Please feel free, unmute, ask questions. If you want to go off on a tangent or something like that, let's do that. This can also be as little or as much of a, I guess, commercial or advertisement for where I work, depending on the questions that you ask. So feel free if you have questions, otherwise I'll kind of be a little more generic about it. So about me, I'm currently the DevOps Advocate at a tiny little Israeli startup called M0. And with that, we are doing infrastructure as code automation and things like that. Hey, no, you're not going outside. Sorry, it's my daughter. You're not going outside. You go. Sorry. It's raining and storming and she's not.
Wow.
Yeah, so.
Go dad.
I am dadding right now. My wife is not here. So, you guys get a little bit of everything. So before
full Tim.
Exactly. So before being the DevOps Advocate with M0, I was at VMware, as Chris mentioned. I was part of a group of people that created the Cloud and Developer Advocacy team with VMware. There is 30,000+ people at VMware that do vSphere and stuff real good. We were part of the few people that we were kind of the anything but vSphere team. We were focused on all of the SaaS tools for native public cloud. Now VMware has kind of shifted its vision and strategy a little bit recently, where multi-cloud doesn't necessarily mean real multi-cloud anymore. It just means VMC on blank. But it is what it is. It kind of happens. There's still lots of things that they have. There's still lots of tools that do work for, AWS and other public clouds, but they're just not hyper-focused on it like they used to be. Before being a Cloud and Developer Advocate with VMware, I was still with VMware, and I was a pre-sale systems engineer in the networking and security business unit focusing on NSX. Before that, I was with Dell Technologies as part of my giant stint of working for Michael Dell between VMware and Dell. I was an enterprise architect there, focusing on VMware and infrastructure. Before that, I was in infrastructure operations at SoftLayer, which is now owned by IBM. As you can kind of tell, the overarching theme of all of this is that I'm an infrastructure guy. That's my background. I kind of happened into DevOps, and I like to make the joke that I am the ops side of DevOps, or I bring the ops to DevOps. DevOps means a lot of things to a lot of people. Some companies just think that it means, hey, we're going to write some scripts and automate some of our infrastructure, and that's not the case. Some people think it's just developers using a CI/CD platform, and that's also not the case.
But you killed my joke now about you didn't spend any time with Urban Code while you were with IBM.
No. When and in fact, I actually left SoftLayer about 2 months before the IBM acquisition. So technically, I have never worked for IBM. But if you ask Fidelity, I have an IBM 401k stale account sitting there because I still had some paperwork in the system. So they gave me a 401k that I absolutely never used. And no matter how many times I talk to Fidelity, they will not remove that account for me. So, technically, I guess I kind of sort of didn't really work for them. But no, it's, overall, I'm an infrastructure guy. That's kind of what I've done. But really, I've always been focused on the application. A lot of that came around when I jumped over to the architecture side. But there's no point in delivering infrastructure if you're not delivering infrastructure to run the application that runs the business. So that's kind of always been my focus. Being Cloud and Developer Advocate with VMware really taught me to focus on the application, focus on the customer, focus on the developer. And that's kind of how I parlayed myself into a developer relations or DevRel type job that just happens to carry the DevOps Advocate title here. But here's a nice little agenda of things that some people might talk about. I'm going to skip that because I don't like agendas. Key terms, things that kind of differentiate here. Static environments. These are the legacy lab type environments that we have all known and probably used, where they don't change very often. You've got a stack of hardware, you have stuff that's configured and built up, you have a copy of your application deployed, and it just kind of sits there and doesn't change much. Dynamic environments are very short-lived, ephemeral environments. You spin them up, you do what you need to do, you burn them down, you move on to the next one. That's a real big differentiator, and that's kind of what we're going to talk about when we're talking about how to automate the infrastructure as code lifecycle here. So why dynamic environments? If anybody here has been in charge of a lab at any given point in time, the question of who's on dev is probably the bane of your existence, or has been at one time. I was the guy at Dell who coordinated the lab. This lab basically had a production SLA on it. It wasn't a lab. It was just where they tested stuff, but it had SLAs that might as well have been production. 2 people couldn't initiate breaking changes at any given point in time. You couldn't just reboot stuff if you needed to, if something wasn't working. It was a real pain. It was very static, and it basically wasn't a lab. It was just a development environment with production SLAs. That's not really the best way to be quick, to be agile, to be able to have multiple people working on things at once. It's not DevOps. Having dynamic environments can also help you to make sure that you're always matching production. Now, of course, you can have that old static lab environment and you can make sure that it's always patched and you're doing what you need to do. But if you're doing dynamic environments that are spun up dynamically every time you need them, It's just pulling from that main branch and it's deploying out with whatever the code is at that time. So no matter what, you don't have to go through patching or matching activities or anything like that. It's just always using a copy of whatever's sitting in the main branch. Also, fewer wasted cloud resources. Now, there are some caveats to this, but it's just one of those things where some people ask, hey, if I'm spinning all of these different environments up, how am I cutting down on waste? Well, if you are spinning all these up, you're also burning them down as soon as you're done with them. So that environment isn't going to spin up and stay up. It's just going to be used and paid for however long you may need that. So that's definitely something that can, be of use when moving to dynamic environments. I've seen copies of this slide used a billion times. I've presented copies of this slide a billion times, and I thought that I was going to be done with it, but it really does just kind of help illustrate why static environments back then were fine and dynamic environments are, more relevant these days. With the application stack, it didn't change much. You may have done a little update here and there, a little bit of a refresh, but not a lot has, changed. So those static environments were all right. These days, with more cloud native architectures, microservice architectures, and things like that, you're updating little pieces, you're moving things in and out, you're swapping stuff out. That allows you to be a little more agile and be a little more dynamic. And that's really where dynamic environments come into play. So developers these days are deploying more and more and more infrastructure. In my side, from an infrastructure perspective, years back, we used to call that shadow IT. That was a huge pain. It caused problems. But you had to kind of look at why they were doing that. And it was simply because public clouds were coming up. They were able to come, swipe a credit card, click a button, and do what they needed to do really quick. I had to procure hardware, ask a change advisory board if I was able to do this and plug stuff in and assign IPs and do all this. I physically could not move as fast as public cloud could. And that fully explains why developers were just jumping out and deploying their own infrastructure behind everybody's back. But developers don't necessarily like to jump in and go through, click a bunch of things, figure out what the AWS portal is, figure out what this weird name that AWS decided was correct today for their service. They just want to figure out what's going on, figure out what they need, speak in their own language, which is code, and shoot a call off for an API and get what they need. That's kind of where the infrastructure as code model came from. And with that, obviously we've got our Terraforms, we have our other things. Infrastructure as code has now kind of become industry standard of ways to deploy and manage your infrastructure in the DevOps space, or really in any kind of agile development space. Now, if we are trying to figure out how to automate our infrastructure as code from deploy to destroy, I wish this was going to be something where I'm just going to tell you, get this product, download this, install it this, configure it this, do this step by step by step. But obviously the traditional engineering answer for all of that is it depends. There are so many different variables that go into how your process might look for automating this life cycle and figuring out how this works, that I really can't answer that for you. So you just kind of gotta take stock, start writing some things down, figure out, make a bunch of choices so that you can get going. And that's kind of what we're going to talk about, is some of the things that you may need to think of, what process order you might need to think of that. And the very, very first one is, which infrastructure as code framework are you going to utilize? Are you going to use cloud specific? Are you going to use cloud agnostic? Obviously, as this is an AWS user group, y'all are using absolutely nothing but CloudFormation, because there is nothing wrong with CloudFormation. It is the end all be all, and it is great. Or you might be using Terraform a little bit, because most people are using a little bit of Terraform at this point. The choice that you kind of have to make is, are you going to use a cloud specific? Are you going to use a cloud agnostic framework? If you are 100% in AWS, CloudFormation is great. It does a lot. It does kind of what you need it to do. There's lots of demos and installation stacks where you just do that. In fact, our product that we have at M0, we have our self-hosted agent. Our deployment uses a CloudFormation stack to go and deploy the self-hosted agent out. So I get it. It's great. It does what it needs to do. But if at some point in time you might be multi-cloud, you might have to migrate from AWS to Azure, which you would never do because you are an AWS fan and you always will be, wink. It's just one of those things where you can't necessarily just take your CloudFormation stack and deploy it on Azure, or deploy it on Google, or deploy it on VMware. If you choose a cloud agnostic framework, your Terraforms, your Pulumis, your Terragrunts, that'll give you a little more flexibility and freedom in terms of being able to deploy to multi-clouds. Now, of course, with Terraform and the providers, they are always different. There may be a little bit of resource difference or syntax difference, but at least you'll be a little bit better off if you went that direction. If you do have to migrate or move or decide, hey, I need this to be able to deploy to whatever cloud, it'll be a little bit easier that way than trying to take the tools and I know there are some out there that will try to convert a CloudFormation to an ARM template or what have you. But that may, not necessarily be the best way of going about it, but it all depends on what you're doing. If you are always going to be in AWS, which you probably will be because AWS is great, and I'm sure they're watching this right now, then, go for it. That's just something that you got to kind of think of. From there, we got to kind of look at where are we and where do we want to be. Right now, we have our applications deployed. We are out in the cloud. We're doing our thing. But we want to be able to move to infrastructure as code. We want to be able to automate that process a little bit. We want to become a little more agile. So you got to think of how you're going to do that. Are you going to start fresh? Are you going to completely re-platform your stuff? Are you going to take your app and refactor it? Blah, blah, blah. All of these other, buzzwords about migration that most people really don't get to do, which would allow you to then go and write your infrastructure as code from scratch, deploy it out, configure everything and figure that out. But a lot of the times, from what I'm seeing for our customers, is they're going through and they're trying to figure out how to do it backwards. They're trying to write infrastructure as code files for the stuff that they've already got. Now that is absolutely possible. For instance, there's a tool out there from Google called Terraformer, and I want to say that it does a little bit of AWS. I actually think that somebody told me this last time I was presenting for you, Chris, for the brown bag. Somebody mentioned that Terraformer does a little bit of AWS. I know it does GCP for sure. But there are tools out there that will help you kind of, take something, point it at the cloud, say, these are my resources, and it will then go and write back what those infrastructure as code files would be. So you kind of figure out not only that, first of all, what framework you're going to use, but you got to figure out your strategy of how do I take what I've got now and how do I make infrastructure as code files? Am I going to use what I've already got, or am I going to write them from scratch and kind of figure out a process to rebuild that from scratch? Not a lot of folks have the ability to just scrap and start over. I have seen one customer ever that just happened to be on the verge of a major refresh and restart. And they just said, okay, well, if we're going to do this, we might as well go all the way. So they were able to just start fresh, do everything. And they went from old school, slow moving, monolithic company to super agile, fast DevOps company. That was a huge fluke, and it just kind of worked out for them. But there are definitely methodologies, there's tools, there's partners and all kinds of folks, especially the wonderful folks at Worldwide Technologies that would probably love to help you with that. So luckily I got to see your face there. As soon as I said that, I was hoping that you would react. Oh, excellent. But either way, you figured out your framework, you figured out your strategy. Now, what do you do from there? Well, we're going to kind of take a look at, first of all, why would you go through all of that? When you're moving to dynamic environments, you kind of get to split the workload a little bit. You have your developers developing on the local machines. They can create their POs. They're doing end-to-end testing on dedicated infrastructure so that they're not having to figure out, hey, who's on dev, who's doing this. They then get to take and work on the shared model of back to main, which then gets to be deployed. Going through all of this can absolutely have a lot of benefits. It can make your developers happy. If you are the developer, maybe you're doing this, maybe it is making you happy. It just allows you to be a little more flexible and a little more fast. Do what you need to do. If you need to burn it down and start over, if you need to reboot it or what have you, you're not going to mess with anybody else. So we've gone through, we figured out the framework, we figured out our strategy for how we're going to do that. And how do we actually do that? Well, you've got to templatize your infrastructure. You've got to do all the things that we just talked about. The reason you're doing this is because you have to have a repeatable template of what you're doing. When you're doing dynamic environments, you're essentially going through, you're cloning down from, the master or main branch, and you're deploying something out. You've got to be able to have that in a repeatable process so that you can do that over and over. If you're having to go through and click and build an EC2 instance, and then click and spin out an RDS, and then connect that all together, and then manually go through and either run Ansible or configure that out, you're gonna have a bad time. It's gonna be a lot of work. If you templatize that, you create those infrastructures code files, you figure out where you need to go, you can then go through and want to automate that and spin that out. Well, how you want to automate that is where you figure out your strategy for these dynamic environments. There are a lot of different ways you can do this. From a GitOps perspective, if you're doing per pull request environments, so that every time they open a pull request, it spins up an environment or updates the environment that they have. Do you want to do a per developer environments? If you have multiple developers working on, multiple things, then they have their own environment, it burns down, they get a new copy of the code, they do their next task. You also have to think about things like time to live, or if you're going to offer self-service for this, or if you're going to need self-service for this, how are they going to spin these up? All of these kind of things come into play when you're trying to figure out that variable of what is my strategy? How do I do these dynamic environments? Once you have that, you can then implement your deploy and destroy automation. There are so many different ways to do this. This is where my giant, commercial comes in for what we do. M0, Scalar, Terraform Cloud, and Spacelift all kind of created this tiny niche in the industry called tacos. I will use that name and I will push and push and push, and I'm trying to make Gartner create a new magic quadrant for tacos. That is the Terraform automation and collaboration software space. Now you can also do this with scripts, you can do this with CI/CD, but really the four of us are making this niche in the industry where we are entirely focused on the entire life cycle of infrastructure as code. With a CI/CD platform, you're going to go through, you're going to process all the tasks, it's going to deploy out the infrastructure, and it's going to wash its hands of it and be done with that pipeline run. Well, what happens at the end of that life cycle? What happens if you need to redeploy the infrastructure because you updated some code? What happens if there's a problem? That's something where one of these specialized platforms comes in to really help you kind of manage that life cycle all the way from deploy to destroy. Now, like I mentioned, you don't have to use one of our platforms. There's absolutely ways to do that. You just kind of have to figure out what works best for y'all. From an infrastructure as code perspective, if you are using 100% CloudFormation and AWS, which you probably are because this is an AWS user group, then you can absolutely automate that with whatever way you see fit. You can use code deploy, you can use all of those other tools in order to do that. You just need to make sure that you're taking into account, hey, what does my code look like? Now, when you are building these infrastructure as code files, there are a lot of things that you need to think about in terms of designing that, such as, say I picked Terraform. Now I have a developer environment, I have a staging environment, I have a QA environment, I have a production environment. Do you want to create an entire set of infrastructure as code files for each one of those environments and put them in their own repo? Or do you want to, say, create one set of files for that, make it, put a bunch of variables, kind of sanitize that, or what they call dry, don't repeat yourself that. That way you have one set of code files where you're just injecting the variables you need at deployment time to either make it for development or for production or what have you. That's kind of one of those things that you need to think about along once you've figured out what platform you're going to use and everything like that. You just kind of got to make sure that you're writing the code files in such a way that you can automate them as cleanly as possible. Now, like I mentioned, this is one of those things where, if I was sitting there in front of you and pointing at, you and asking questions and stuff like that, we can make this last for 45 minutes, but it's really not a ton of content. If you want to follow me and find out more, please feel free to. If you have questions, feel free to let me know. I'm here for you.
So a couple of questions about the process. You were saying that it fits in with. So first off, Just because this is an AWS user group absolutely does not mean that we are merely product fanboys that only use CFTs. We've actually
I would hope not.
Well, I mean, so we've had Azure speakers on. We've had a number of different service comparators, if you will.
That's awesome. Yeah.
So this is not just a group of Tesla fanboys to
homers
that insist on using that. So in the V Brown bag that you did for us, you had a little demo of tearing up and tearing down an environment, and I think that a lot of us here can understand the value of having a dynamically changeable environment. Can you speak a little bit more about some of the things that you're seeing in live customer environment without names or anything like that? But what are some of the cool things that you're seeing that's happening out there right now?
Yeah, we have a lot going on. The industry is interesting. We kind of fit into a space where a lot of folks lump us into the CI/CD category, which we're not, because, well, first of all, we don't do CI at all. We do CD, but it's really that day 2+ operational value that we bring that kind of sets us apart from that. And with that, you guys have, I'm for sure probably heard of Terraform. I would imagine most of y'all know that Terraform has their own product exactly like ours called Terraform Cloud that helps you do exactly this. It helps you, you point it at the repository, you tell it, hey, I want to deploy this, and it helps you go through, spin up what you need to do, and take care of that. One thing that they're not figuring out is from a self-service perspective, how does that look? From a role-based access control, how does that look? Now, of course, you can pay them a pretty handsome sum of money, and they will throw role-based access control into there so that you can kind of manage who's going to be doing this, where are they going to be doing it, what variable values are they allowed to be doing that in. But something that we saw that
Enterprise?
wasn't being yes. Well,
okay.
Terraform Cloud Business does that as well. So there's business and there's enterprise. Enterprise is the on-prem version. Business is the SaaS version of basically the same thing.
Gotcha. Okay. Gotcha.
But yeah, you can pay them a handsome sum of money, and they will allow you to use role-based access control and kind of allow people to jump into the system, deploy what they need to, manage that lifecycle. We kind of saw our customers looking out and saying, hey, we need to set up this self-service, but we want to make sure that there's some guardrails on. We want to make sure that we can run open policy agent so that they can go through and deploy, but they can only deploy to this specific region or this many Kubernetes nodes at a time, or only this size of instance. Now with Terraform Cloud, you can utilize Sentinel, but it's one of those things where that is, of course, vendor locking, because you cannot take your Sentinel policy with you somewhere else. If you write Sentinel, it's good in Terraform Cloud. I'm sure there are some hacks around that to be able to run that elsewhere, but for the most part, Sentinel is locked into Terraform Cloud. Open Policy Agent is basically what Terraform is to infrastructure as code, kind of the industry standard open source. Open Policy Agent is the policy as code framework that has kind of taken over as the industry standard. We allowed people to utilize policy as code so that they can kind of create that self-service portal. They create their templates and they assign them to projects inside of our environment so that they can go through and say, hey, for development, I need an EC2 instance, or I just need application stack A, and deploy it out. Well, if you choose a instance size that's too large, it'll go ahead and cancel that out so that it keeps your guardrails on. And we're seeing a lot of folks that are liking that, because when it comes down to self-service, you absolutely want to enable agility. You want to take these dynamic environments that you created with infrastructure as code and allow people to do what they need to as fast as they need to, but you also need to make sure that you're maintaining control. Nobody wants to get yelled at the end of the month because they're over budget. Nobody wants to figure out what their brand is worth to them because they were breached. So making sure that you are shifting that security left into the deployment process will really allow you to kind of keep that control, so that if you do have a security misconfiguration, it stops it before that's deployed. And that allows you to kind of take the reins off while still keeping the reins on, if that makes sense. And that's definitely something that we've seen, that customers are looking for, that we kind of saw from the beginning. We kind of focused on the self-service use case. Another thing that, kind of is out there is there are so many other frameworks. There are a lot of things out there. Terraform seems to be the biggest one. That's what a lot of people are using. A lot of folks are using TerraGrunt. A lot of folks are using CloudFormation and ARM and all of those. But then there's Pulumi. Pulumi is catching traction. It's, coming through. It's doing what it needs to do. A lot of folks are liking that simply because it allows them to do infrastructure as code without having to learn a new language. For any of you that aren't necessarily familiar with Pulumi, it is infrastructure as code, kind of like Terraform, but with Terraform, you have to learn their language of HCL. You have to be able to write that to write your Terraform code. Pulumi allows you to do infrastructure as code using whatever frameworks you're already using. If you're doing Node.js or Go, then you can write your infrastructure as code in that same language. That's catching on a lot more simply because they don't have to learn a new language. They just have to kind of learn some new syntax and stuff to figure out how to, shove that in there. Now with that, if you are using Terraform Cloud and you decide, hey, I want to try Pulumi or I want to deploy some CloudFormation, well, you can't. Now you could script it in some way if you really wanted to, but it's just one of those things where if they're not focused on that. Terraform Cloud is focused on Terraform. Ourselves from an M0 perspective, as well as our other cohorts in the Tacos space lift, we are both focused on bring whatever infrastructure as code you want. If you want to use Terraform, great. If you want to use TerraGrunt, great. If you want to use Pulumi or ARM or any of that, great. Bring that and we'll help you deploy it. We see that as a good strategy going forward because we're kind of keeping that open because from a multi-cloud perspective, we do have customers that if in their AWS, they're using CloudFormation and their Azure, they're using ARM. They want to be able to manage all of this at the same time without having to work from different platforms. They want to be able to offer a self-service portal that does all of the things in all of the clouds. So that's definitely something we've seen out there is that, while a lot of customers are using primarily one infrastructure as code framework, if they are across multiple clouds, they're using multiple frameworks.
I'd like to jump in with a question. So when we talk about all of the guardrails and certain things that you're talking about there, I'll share from a developer experience. One of the things I loved about the AWS CDK was that you could write it in a declarative language and I could start writing unit tests against my infrastructure as code. So again, as an engineer, not with that DevOps background, not with a focus on that area, but really focusing on writing code, unit tests, which are really common to how I deliver features today. Being able to have that with my infrastructure as code seems like a huge step forward for me. If you're not using CDK, you're using Terraform, you're using others, what are some of the guardrails around testing the infrastructure as code in a way that you might unit test a CDK?
Yeah, absolutely. And a lot of the things that we see, like we have a feature called custom flows, which allows us just to drop a YAML file inside the repository. Then during the deployment process, we will parse that out and put whatever bash commands that you put in there at whatever stage you want. So for example, if you wanted to do security testing using like Checkov or Terrascan or something like that in the deployment process, then you would just say after the Terraform plan, and then you would, pip install Checkov into the container and then run that. So doing your testing and things like that with infrastructure as code, if you're just doing it on the laptop, which is what a lot of folks who start with infrastructure as code, you just do your Terraform init, you do your Terraform plan and apply right there from the laptop. It can be difficult to write and implement these unit tests and other testing that you need to in the deployment process. Utilizing either a CI/CD platform or one of the Tacos platforms can really help you get a handle on that and be able to inject those steps into the process, as opposed to just utilizing the raw deployment commands on the laptop, which aren't really cohesive to all that testing before you actually apply it to your infrastructure.
Yeah, so I think I wasn't necessarily talking about how to run my unit test. I was talking about, so with CDK, I can write assertions against my infrastructure as code that says, I have 3 Lambdas. They each have permission to do KMS decrypt and are part of this VPC in this subnet with this IP range. So I'm asserting against the infrastructure as code definition, the CFC that's going to get written later. That's kind of the direction.
Sorry, I misunderstood what you said there. No worries. So the way to fix that with infrastructure as code, that's going to be Open Policy Agent. That's going to be where that comes in. Open Policy Agent, they have what I consider to be a god awful language called Rico that you write their files in. And with that, that's where you're able to then go through and write those tests and create that policy framework against your infrastructure as code files. For instance, you can write a little bit of policy that then goes through and parses the Terraform plan and says, I'm only going to allow T2 medium and T2 large. I'm not going to allow anything, other than that. So that allows you to kind of not just create that those unit tests, but actually create that policy framework to check against. And then what will happen is right after you run the Terraform plan, you then create a little script that runs that Open Policy Agent against the plan so that it says, hey, the plan told me these are all resources that I'm going to build. This policy file is going to check against that and make sure that everything is within my parameters. If not, I'm going to, kick an error code. If I am, I'm going to go ahead. So that's really how we're seeing customers go through and make sure that when they are writing these files, it does stay within the, kind of the compliance parameters that they're looking for.
Awesome. That's exciting. Thank you.
For sure. And for any Terraform Cloud users out there, the Open Policy Agent, that Sentinel is exactly what that is. That's just their version of it.
We've got people posting links up in the chat.
Yeah,
channel.
this is great. I see like a link to Pulumi and Open Policy Agent. Yeah, there's so much cool stuff out there. And Open Policy Agent, it can seem daunting, having to figure out how to write all this stuff. But the good news is, because it is kind of the industry standard at this point, somebody has probably already had whatever problem you're trying to solve. There is a random GitHub repository out there with the answer to any, how do I stop this from happening? Or how do I create a policy for this? There is an answer out there for you. So it's absolutely great for that.
Hey, Tim, do you see a big uptick in microservices for DevOps? Because I've noticed like everybody's talking about things like, Kubernetes and containers and whatnot. How is it, for you guys over there?
So, and it's funny, Kubernetes is kind of the big new thing, and you hear about it constantly. And, KubeCon just finished up and it's huge. I legitimately cannot think of a single customer of ours that is automating Kubernetes clusters with infrastructure as code. Like if they're using Kubernetes, it is not in scope for what they're doing, their Terraform and stuff like that with. So it's weird. I mean, I know like microservice architecture, like utilizing all the AWS services and stringing them together, that is definitely big. We're seeing a lot of that, but Kubernetes specifically, I'm simply not seeing that, but that also may be because most of our customers kind of find us as the Terraform alternative and they're using Terraform, and the Terraform Kubernetes provider is a dumpster fire. It is awful. It has problems. Everybody's tried to fix it and it hasn't gotten fixed yet. So that just may be why I'm personally not seeing a lot of it, because most of our customers are focused on Terraform, and Terraform Kubernetes is kind of a nightmare. And even like EKS in AWS, the single deployment demo that I have that causes me more problems than anything, if not one of the only ones that actually causes me problems, is my EKS deployment demo. I mean, Kubernetes has so many little moving parts and so many little things that can go wrong. Trying to figure out and automate that with infrastructure as code, at least, and even trying to sanitize it so that you can templatize it and deploy it over and over and over, it just causes a lot of problems, and we just don't see it as often. Now, of course, there are customers that are out there doing it. We just don't see it.
Thank you.
Absolutely.
Just don't say that at KubeCon. Wait, what?
Yeah, it was a big deal. I didn't see a lot of it live, but got to catch up a little bit. I mean, the Kubernetes community is huge. If you're not on Twitter, I highly recommend you get out there. The Kubernetes, and especially the InfoSec Kubernetes community, is awesome. So much gold comes out of that. If you don't follow Ian Coldwater, you absolutely should. I mean, it's really cool, and there's a lot going on. But from a DevOps perspective and what we're seeing for infrastructure as code automation, absolutely yes, microservices. Not really on the Kubernetes side so much.